That's, where is it? Just need this much. Yeah. Okay, alles gut. So today what we will be doing is solving some of the work that I've been put up with. And here in this project, what I need to do is to calculate the sentiment score for papers, a lot of papers. Um, and what else? Excellent. Okay, let's keep this. Can I make it like hmm, perfect. Yeah. Okay, perfect. Perfectly said. All right. I can see a lot of things. So calculating sentiment scores for uh, each of the papers that we have, which is mm, very hard to do. For example, this folder here, where is it? This document process. This is over 1 million papers related to COVID-19. And this is the COVID-19 dataset, which has all the papers, I believe, all the papers of the during the COVID-19, the scientific literatures and everything. So those papers are going like exist in these two folders, which I'm like reading now. The lens are, you can see. Okay, so I do not want to open it from here because it will just crash it. I think I have some open in my notes. The schema, not the schema per se, but one of the papers. Yeah, this is one of the papers. Not sure if you can see it. Let me just zoom in. We've got the paper ID, which is, for our case, it's not relevant because we're not using the ID to, we're not using the ID at all. And there's a title, we will use the title. And what we are primarily focused on are the text blocks. Whether it's on the abstract or the body text, it doesn't matter. We are primarily concerned about the text blocks because we are going to put the text blocks in one of the Hugging-Face models, which is this one, and it will give us the sentiment score of that particular text, which I plan to aggregate and then calculate the final score, of the entire paper. What is the main idea? What is the main end goal is that to make a cluster. Each paper, like there's a million papers. Each paper will have a distinct sentiment score ranging from 0 to 9 or 1 to 10, 1 being the lowest, and then 10 being the most, what, like good in terms of like sentiment in the text. And that will be distinct values from 1 to 10. That will make us form 10 clusters. Now that I am saying it out loud, I think the better way to do is with not 10 clusters but 100, because for a million papers, wait, is it, there are a million papers here, but I don't actually need to do from the knowledge graphs on all the papers. Rather, there's a sub thing here titled paper map, which is a JSON file containing around, okay, that's a less, 56,000 papers. Yes, that's way less. That's way less. So the idea that the reviewed idea was to create not 10 clusters but 100 clusters, because we get the data, we get the sentiment scores in a range of 1 to like star wise, like 1 star to 5 stars from this particular model that will which I have to use to have a consistent score of 0 to 1, which I can multiply it by 100 to get 1 to 100 distinct scores for the papers, and according to those scores we can cluster the papers. Yeah, that's the idea. So first idea is to get the, and lastly what we need to do is to forget all the text, because what we concerned about is the sentiment score. And when we have sentiment score, we just form a pandas data frame with all of the names and the sentiment scores, and that will help us to make the knowledge graphs or whatever you call it. Okay, now problems. Yeah, this was the problem that we're concerned about. Okay, first of all, these are the papers that we need to find from the million papers that we have at the moment. The problem here is that this one and one of the papers that I will just show you again, this is the title of the paper that we have, and these are the titles of the papers that we need to query from all of the million papers. You see the problem? I think the problem is apparent here. Problem here is that here it's with the string, because we need to find and match the string. Because if we search for this particular string on this list of titles, we're not going to find anything if we try to match the string to string in an exact manner. So what we need to do is to remove the spaces from here, remove the as there are other things. Supposedly there are no parent punctuations, rather than just like this here, and what do you call that, dash, and there are, I don't see it, there are numbers. That's fine, we don't care about numbers. The numbers will be there. There are no capital letters. The COVID are just lowercase letters, and I also see an underscore, which is good. I have to keep the underscores as well. Let's look for other things. I really don't know what happened here. Okay, that's a jump because that's going to stay. So, oh, okay, so we are also considering the slashes. Hard to say. Anyways, let's not like think about the slashes right at the moment. Uh, what else? We have the ampersand, which is fine. I don't see anything else that we've missed. Of course, okay. All right, I think I did use a code which will extract everything, like make everything lowercase. Yes, this was the clean title. I'll replace the spaces with nothing, and then it will make everything lower, and then replace this one with nothing, remove the full stops, remove any commas, any semicolons, any brackets, question marks, exclamation marks. This one I don't need to have this because there are dashes. Not sure I'm going. I would need these. The star is fine. Okay. Yeah. So let's just copy these things because we need to find. Where is it? 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 Sentiment analysis. Okay, I need to make this a bit bigger because I need country graphs, graphs. Yeah, I'm starting the sentiment analysis here again. Why? I don't know. I've almost already started this. This was a test earlier, I think. Yeah. Scoring negative. Okay. I can work with this part. I don't need to go back and forth from the last part. So let's work with this part. Okay. From here, let's start anew where we need the OS. We need the pandas as we're going to make it a pandas data frame. Wow, what else do we need? I think we need more things, but let's just keep it for now. Let's do, okay, I need TQDM and JSON. Import JSON from import TQDM. I'm not sure why the IntelliSense is not working. Or the GitHub Copilot. Right. Well, let's saving time. Let's copy some of the things. We are going to read the paper entries. No, we're not going to read the paper entries. What we will be reading is just querying it from paper entries, right? No, we're not. We will not do the paper entries at all because that's a very large file, and the paper entries has something different that I don't want actually. Okay. What I do need to extract is the titles. The titles. Extract the titles. And I'm thinking that do I have to, like, should I also extract all of the texts as well in an array so that I don't have to loop through it again? hard to say. You know what? Best way to like go through this is that, let me explain it. This two folders has a million. Why is it not working? I need to restart it. Taking a bit longer. Okay. Save and just get out. Ooh, just crushed. Okay, right, cool. That did not save, of course. All right. Okay, just loading the Python and whatnot. So the idea is, like, let it load and I'm just gonna explain the idea. Is that we have a million here. There's like 401,000 and 315,000 PDFs of literature here. What we need, and from there we need to find the 53,000, these 53,000 or whatever, 56,000 papers. We need to like filter them, and from these only we need to do the sentiment analysis and then create a data frame and those kind of shit. Okay, so let's just start. I think we can work now. Run. Yeah, it's run. Good. Okay, now we can work finally. All right, so we know that they have these, and then we need to loop through this. So let's copy it one so that we can have less headache in the future. Okay, so we have to loop through these and extract the titles. So extract the titles, the papers. Is it Copilot analyzing? I don't know. I'm going to work on this for an hour, and then I will switch on to a different project, which is a more exciting one. Okay. Do you have something for me, Copilot? I'm just going to analyze stuff. Okay. He does not have anything for me. So these, I will copy this, but I will obviously not have that. Yeah, I will not be extracting the text now because that's going to filter, because this loop is going to loop through the million papers, like almost these amount of papers, but I don't have to, and then it's going to filter out only 56,000 of them, and that's and put the names of those papers in a new list, and that I can use that list to, like, extract the text, so that way I'm saving a lot of RAM and the CPU power. So not extracting the text while iterating over the million papers. Now just extracting text when we are just iterating over the 56,000 papers. That's repeating. Okay, let's start the loop. Going to this, and then load the data with the JSON, and then I don't need the titles. I don't need this. I just need the titles. Will have the list here, and then come on, Copilot. I don't understand why the intelligence is not working. Hmm. Something's wrong. Yep, and I cannot work with this. Uh, I don't understand why they're not working. Fine. And it's just, why is it working like this? Sure. Down and see if it. Sure that it's not putting too much pressure on the PC. Oh, I'm actually getting live in 60 FPS, which I don't actually want. Because I'm not streaming a game. Okay. Weird. Very weird. Just close everything down and just let it work. Hmm. Cool. So let me run these two, which is going to take some time. And it's not working. Not sure what's the problem. Honestly. When I try to save it, it's the problem. Let's just wait for it to save. Okay, saved it for some reason. Okay. Yeah, I want you to use as much resources as possible. No problem with that. Yeah, the sentiment discourse. I think the Copilot is also working at the moment. Okay, do not, please. Let's copy this here. And then let's write. Just print the length. I don't think you need to do that again. And that's the problem with working with large amount of data, guys. Around 5 gigabytes of my memories have been used by the Visual Studio Code. 5 gigabytes of my RAM. Just simple length operations not working. Work here is fine, but now it's not working in here. This is just disappointing from the studio code, honestly. Like third time I'm just waiting for it to complete. Yes. I don't want to close it again because I'm sure it's not saved. For some reason it's not even working. Crazy. Just know what to do, but I cannot do it because it's just crazy. Save it. Just stupid. Anyways, let's move on to our next project. It's just wasting too much time here. This is more of a interesting one because I am actually developing a system, emotion recognition system with some of the things that I know. Okay, let's start. Okay, where was I last time? All right, this was the model. That was, yeah, this was the entirety. Mhm. Mhm. Yeah. I have this. Okay, let's just. Um. Uh, yeah. See, here it works fine without any problems. I don't know what was wrong. Okay. Let's see what was the problem. The problem, what I was working on was um, having a recognition model so that hmm, face embedding. Hmm. Video capture starting. Oh, I have written down some things in, yeah. Where was it? This project folder where you test the config.json, which has the emotion model, the emotion detection. Yeah. Cool. The problem, I was developing this part of the. Can you see that part? No. Okay. Let me. This was the part. Yeah, this was the part. Hmm. Let me concentrate on this so that I can like solve it. Hmm. With a unique ID. So unique ID is a unique ID. Okay. This was the problem. Okay, detected for emotion. Or that will be pinned. Yeah. Mm-hmm. When we have the prediction, we will count the prediction, and then we will when there's a phase, there's a prediction, oh, sorry, there's a motion, and then we save the motion into the unique ID. Hmm. Mhm. I'll give the unique ID here, and if this is not close, it'll this part will check. Let's write it down. Check if the numerator is close to any other embeddings. Okay. Yeah. And then if it is close to any other embeddings and the confidence is high enough above the threshold, it will return that existing ID that it already has on the dataset on the dictionary here. Okay, and if it doesn't, we'll just create a new unique ID and then create an embedding, add the new embedding, and then have an emotion counter, which will give and return the new unique ID of the user that we just added into the dictionary. That's what these two blocks are doing. That's just completely fine. However, what we need to do is to like count the emotions now. So when we had the prediction, uh, session, there's no session or something, it's just deleted. It was just the code before it. Okay, so emotion, there's the emotion count, and then get the emotion dictionary. Where is that? The emotion dictionary is here, and then the prediction of whatever it is there, that will give us the this part, the string, which we will query here and then increment the value. That's what we're doing here. Just increment the value for each of the detections. So for if there's like two phases, for each of the detection, it will like get the unique ID and then increase that specific unique ID. Now, what I have to develop at this moment is that Uh, so the idea is that someone is in the camera and I'm showing an emotion. Emotion is being tracked each frame. So this frame I'm happy, next frame I'm happy, for the next 10 frames I'm happy. So that the happy counter is um, increasing. So when I'm not in the frame, like I am not in the frame, it will count a specific number of frames that this specific individual is not in the frame. Gosh, this is tough. This is a tough logic. The specific individual is not in the frame, and if that condition is met, that this specific individual is not on the frame for a particular number of frames, then it will send the data, whatever it captured, to the MongoDB database and then clear out that part of the dictionary. That's it. So how can we solve this? When we get the detections, we get the images and everything is good. But regardless we get the detection or not, regardless we get the detections or not, we need to check the detected individuals are in the frame or not. So so if there's no, if there is nothing in the frame, so okay, let's just, if there is no faces detected on frames within end the session, yes, this is the basic logic that I have. For example, 10 frames. But but consider this in head with that I'm not here and a different person is here. So I'm not in the frame for 10 seconds, but there is a face in the detections. So this part of the logic will not works. But what I want is that you what I want is to search you get the frames, for example, from the first frame, you get like one face and then you add the face to the dictionary, add the emotion or whatnot. That's not my concern. The next one, you also get one, which is my face. Here I need to check there should be something else. Last seen, interesting way. Last seen datetime.now. I can use the last seen. You get the face embeddings. If the particular face is Color is face not detected for some time. End the session. Send the data to the database. Not really now. You don't send the data again to the next sentence. Okay, this is just looping. This is why the AI is good for sometimes. And you need to know what you're doing. Create a function for that. This end session. Motion count on. Okay, let's see what the copilot gives us. It's sending the data. And this it's ending the session. It's this part is fine. It's sending data to the MongoDB. It's fine. It's just counting something. Emotion count. No. Session emotion max. No. This is just wrong. This is just wrong. Or I don't know. 2 second. 2 second. Okay. No. It is going somewhere, but it's not. It's not going to be like this. Let's think about it. Then we can code it up on our own. When we have the embedding, we check the embedding. Check if those persons are in it's like check person present, deaf person present, present, embedding dictionary. It will have the embedding where's the embedding dictionary in our case? Return false. Yeah, this is the correct way. Need to open the last scene. This is for the new part, and that is for the old part. Yeah, date ended now, and last seen is more than 2 seconds, and then we need to if it's not there for 2 seconds, then we send the data to the data set and then remove the uh, hmm, the start time will also, there's a start time. Yeah, where am I using the start time? Yeah, no, this was have the start time, but I've been there. None, but I will use the start time to last scene, and there should be a start. Hmm. I don't need to give it here. I don't need to give it here. Let's just remove this. This illogical to be to write here and to write here. Just give the data dot now. Every time. If they find the embedding, this is when the new embedding is being created. Yeah, edit. This is where the new embedding is created, and then there's a last scene, and then there's a last scene there again. Last scene is getting updated when we're not finding it. Okay, cool. Cool. Okay. Ooh, okay. Yeah, here we are getting the person dictionary, and then we're looping through the dictionaries. We loop into the dictionary, and then we are getting the time, the last seen time. And then if the last seen time and now is like more than the 2 seconds as expected here, we send the data, as well as we will end the session. Yeah, of course. So session duration is start time. Yeah, that's why we did the start time and the emitting the pop the unique ID. Send it to MongoDB. The data will be MAC address and camera test one. Right. Session duration. Okay. Anything else? Collect, insert, return true, and false, and return true. No. This function will loop in each time if there is a detection. If there is also no detection, that's the problem. This should detect in here. This is the part that no, come on, come on. This is the part. It doesn't matter. It doesn't require frames. It doesn't require any motion. It doesn't require anything. You just do it every single time, and you don't have to return anything. You don't have to return anything. Yeah, it's just here present person that embeddings dictionary. Okay, so let me go through the loop again. So it's while true is reading through the cameras, and then let's consider the first frame that's being read. This is the first frame that's being read, and then we have the detections or not. But if we don't have the detection, we have an empty dictionary. That's cool. With an empty dictionary, this part will not work. This loop will not go through, and then it will just skip the loop and then continue on with like the rest of the code. Okay, so we have got some detections, but detections are not important here. We go through the present person present. I should find better name. Do you have any ideas for better name for this function? I don't know. We go through this function. We give him the embedding dictionary. For the when we're starting it, the embedding dictionary is empty, and it's empty now. So for the entirety, it will not work. So it will not send any data. That's good. That's what we want, because there is not no data to be sent. So we are not sending data. Cool. So we there are some detections. Supposedly there is one detection only. There's one detection, which is my face, and then so this is going to work once. Detected before, I don't need it. It's just a redundant thing. There's a detection, and then I get all of this, and then this, and then I get the frames, because I need this to get the, sorry, I get the face, and I convert it into gray because I need to send it to gray. This is just stupid. I know I should have found some better way to solve it, but we can work with this. Reshaping, and then we get the face embedding using our embedder, and we are adding the embeddings. Right, now let's go to the adding embedding function that we have. So the embedding, we get the embedding and the new embedding, the embedding dictionary, and the threshold. Okay, for existing ID and blah blah blah, this will not work because we don't actually have anything on our dictionary at the moment. So it will create a new unique ID, add the embedding, in the new unique ID, at the motion, like at the motion counter, like it will set up the counter at the start time and the last seen time, which will be the same in this case. Yeah, and then it will return the unique ID that it created. Cool. Now we get the unique ID. Remember, this is just the first iteration of this loop, this loop, this while loop. Okay, yeah, so we get the face embedding. No, we get the unique ID. Yeah, when we get the unique ID, I reshape it again, and then we send the prediction for the emotion. We get the emotion, and then we use the unique ID here to update um, the dictionary that we have. Right, cool. That's just updating one emotion. Then we get going to the next frame where it is showing my face again. Okay, let's go. So it is detecting something. So the detection array has a few things in it. Now it is working. Now this function will go through. Right. Embeddings dictionary. It will have the embedding dictionary and the items. There will be just one item that like it was before. And if date time now in the last scene is more than 2, this part will not work because it's not more than 2. Simple. It's not more than 2. We'll skip it. This part will not work, and then it will again get my boxes and everything, and then it will find my embeddings, and then it will go to the add embedding function to add my embedding again. So now it will also look through this part, and then if the embeddings are close, it will return that it is close. So if it is close, it will just update the last seen part of the dictionary. That's it, and return the existing ID. And the unique ID is here, and then we will again increment the counter of the unique ID right back. Hmm. So this goes a couple of frames, the same procedure goes a couple of frames, and now there's like two there are two scenarios. The first scenario we need to consider is that when there's no faces in the frame. And the second scenario we have to consider there's a different face in the frame. Cool. Starting with the first scenario. Different face in the frame. So starting the loop, it's get detected because there is a frame in no, sorry, starting with the first scenario, which is there is no face in the frame. So the detection is empty. Detection part is empty. Cool. But we have something in the dictionary because the my face was getting like, like counted. So we go to the person's present function, and then we calculate this part for each of the embedding. There's only one item because there was only one frame or one face. So this gets calculated, and this does not meet because it's just the next frame. So this doesn't work. This will not work. This will get skipped. Not work. I mean, this will get skipped. This part will get skipped, and for the detections, there are no detections, so this part will also get skipped. That's fine. No faces in the frame, nothing. And then in the next frame, there's also no faces. So this no face frames go on for supposedly 2 seconds. So now is as 2 seconds has passed, and then there's this detections. And I found a problem when you're sending the data. Session duration is end time, total seconds. When you are not detecting it for 2 seconds, right? End time. End time is now. No, end time is not now. Total time delta? What the F is that? No. Def time? What is this? Let's ask Copilot because he's the one who gave us this. Can you make your mic just a tad loud? Of course I can. I was not aware that the mic was not loud enough. Sorry. I'm good, Justin Musty. First time chat. Hello. I guess it's fine now. Okay, so end time is the time delta is a class in the datetime model of the Python. Okay, datetime model. I did not know about this, so let me go to the datetime. I am working on a project. Let me explain it in a second how to import it. I'm working on a emotion detection project where emotions get detected using the camera, and then when the face is not detected, when a particular face is not detected, it just sends the emotion data to the MongoDB database. No, it is not important. Apparently, I did not know there was a function called time data. Inexperience sucks. Okay, so there is no time delta. Okay, so I have time delta. Where was it? Yeah. Okay, so now I get the end time, and okay. Yeah. Okay. Cool. So where was I explaining? I was explaining it fully. So the 2 seconds have passed. So we get the 2 seconds have passed, and then this part of the code becomes true because the 2 seconds have passed since the face is not shown in the camera. The face is not seen by the program. So, mm, so as 2 seconds is passed, so this part becomes true, and this part of the code will run. Now we get the session emotions, which is the maximum emotion that we can get, and we get the end time, which is the date time dot now, and when it's end time is I had to use the time delta function because I had to subtract 2 seconds because the phase ended 2 seconds ago. So yeah. So yeah, the phase ended 2 seconds ago, and then the session, I get the session duration. It's getting the total seconds here. This is session duration, and I am removing that specific unique ID. Cool, 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 cool. And that's the data, and then I'm sending it to data, the MongoDB. So that for the first scenario, that is just out. So for the first scenario, as the face is not detected for 2 seconds, as the face is not detection for 2 seconds, the data gets sent, and that specific embedding is out. And then, as there's no embedding there for the next loop, it's for the next this while loop, it will not loop through, and if there's no detection, this will not obviously work. And then if there is detection, there will be an add embedding, but there will be a new add embedding because there is this part of the loop will not work, and then this cycle starts again. You understand it. So considering the second scenario, the second scenario is that the different phase is seen. Cool. So we look through it. The detection, the embedding dictionary has one embedding, which is my face, and then a different faces here for this iteration, a different faces here. So we get the frame, we get the detections because there is a frame. Sorry, there is a face, so we get some detection. We get one face detection array or list, whatever you call it. So there's a person present will run, but yeah, it will run. As there is only one on the dictionary, it will run, and then it will check if it's 2 seconds. But as it's just the next frame, the previous frame was the last frame that this face was seen. So this if statement will not work. So we'll just skip. So on the detections here, as there's a different face, and then they will get the face and everything, we'll reshape it, and then we'll get the embedding. The embeddings, remember, the embedding is different from the previous face, as this is a new face, and then there will be an add embedding. Okay, we go to the add embedding here, and then we compare if there is a closer embedding, but there is no closer embedding because the last embedding and the new face embeddings are quite different, and it will not meet in the threshold. So it will loop through all of the embeddings if there's more, but as there's only one, let's just loop through one and check if that specific embedding is closer to the new embedding that we're sending. And if as this is not close at all, it will this part of the if statement will not work, and then there are that's a new embedding that's being that's the second embedding here that's going to be added like this. So again, unique ID, embedding, new embedding calculation, and then last seen, new start time, and whatever. So there's like two. If it comes to last scene will be updated. Adding embedding. Last scene will be updated, and then the last scene will not be. Yeah, I think this is better. This is way better. So this part of the code I don't need because the data is being sent by this person present, which is a stupid name. If data sent face detected this data set to data sent duration, face detected these I don't need these things. I'm sorry. I'm so bad at testing. I know there are quite problems. Yeah. It will show the frame. I don't even need to see the frame. And yeah, that's all. That's all. Okay, a lot to unpack for someone like you. Impressive. Okay, thank you. What do Python? I haven't done anything like that. Yeah. Anything AI that do you mean AI as in the artificial intelligence or okay, never mind. But you should try it. It's like yes, you are right. That there is a lot to unpack here, but it is like for now, I'm using the Jupyter notebook. I also use the Jupyter notebook to test out my things when I am writing dummy codes and stuff. What I need to do for my client is that I need to send him this particular project folder, which has a specific these codes more in a structured manner. That's what I'm trying to say. So you have the run.py file, which will run the file. And then there's this MongoDB server, and then there's the motion detection. There's like unpacked. Now, what I need to do now is like I've added a few of functions, which I will have to is camera available. Is available cameras. This is something that I need to focus on right now, because you see what I did now was for one single camera, and I need to do it from multiple cameras at the same time. That's the problem. That's not the problem. That's the complexity that I have to solve after I'm done with this. Because the client says that there will be multiple cameras. I don't know how many. So as there will be more and more cameras, I need to do it in a dynamic way so that all of the cameras can get looped through. And I also have to make it cleaner. Did I import datetime? From dim at datetime import datetime. Comma. Cosine is from this part. What else? UUID has its own package. What else? Collection. Need to send the collection as well. Interesting. Collection, yeah. Oh, I can set the collection, of course. Let me write this here. Oop. Let me clean up. Motion detectors start detection. I need to see this. This is a start detection, cells are true, and blah blah blah. Send data, so I just send the data. Frames. Scheiße, this is, oh my god. Detect faces, process emotions. Oh my god, okay. From functions, import send data, comma, embedding, comma, is embedding code. I don't think I need this. Send data, there's also send data here. Oh, too much. Not accessed. Why not? It's just the function beside you, right? Motion data as a face without frame. These three, these four, I don't need. Motion count is something that I need. No, alright. Let's just put it. Okay. Detector. No. TCNN. No. Don't break, please. size. Hmm. Hmm. Detector to inputs. I'm not using the detector anymore, am I? No. Cool, cool, cool. I don't need the function at all. This is what I need. Oh, what's the control? Oops, scan. Yeah. Is embedding. Hmm. Rather than dot send data. Hmm. Fair enough. Fair enough. Self dot collection. Where's the collect? Interesting. Collection should be something, right? Here is the collection. Yeah. Oh. Why am I sending the collection name if I'm not even using it? Yeah, I'm giving the client. Is there anything else that I'm using it for? No. This is the MongoDB handler. Example server, I get the MongoDB handler. Insert data. Insert data should be the one, yeah. So rather than insert data, yep. Good, cool. What else? Yeah, okay. So let's read it from here. Well, the self true. You captured frames using this function. process, detect faces. Capture, detect crop face. What? What the hell? Interesting. Hard to understand. Okay. No camera available exiting the program. So you exit the program if there's no camera available. If there are cameras available, it will append the cameras to the range of cameras. So in the available cameras array, and then it will root through the camera ID and the camera array and starting with the camera feed of. Here's another problem. Dealing with multiple cameras is the problem. For each of the camera, I have to just send them. Just send them the entire camera array for it to catch. Then it will have to use it. Okay, this will remain the same, this will remain the same, this will remain camera IDs. Right, there should be camera IDs. And there should be the caps. Good enough. There should be different caps, and all of the caps will be in an array. Good enough. There will be, for each of the moment in time, there will be all faces, all frames. Let me fix here, I'm not just. Yeah. Please. Yes. Please. Do I have to do anything after that? Start detection is the process. Okay, so we've got a bunch of caps, bunch of frames for the first moment, and then there's the detection. Okay, let's go to the detect phase and see where it's getting. It gets a bunch of frames. Can I send him the bunch of phases? I need to test it out. At the same time, that is. And an array. MGCNN face detector. Image array. Image. Will it work? That's the question. Oh, no, doesn't work. Simple, doesn't work. So loop through the frames, give each frames at a time. And no, it's not the detections, that's not detect. Okay, phase detector. What? Phase detector? Okay. Fine. Phase detector. Detect frames. You get the detections. And for processing, right here, this will be an array of arrays, right? Get the detection. There should be an array of array. Detection frame. Detection dot. For particular frame and like for all. This is going to be a, write this, a list store to list to store detection for all frames. Just for understanding. Then I give the array of frames to it, and I get the array of arrays known as the detection. If detection is not known, so if the detection is blah blah blah, I don't need this. Let's just comment it out. I'll delete it later. Okay, cool. Now the detections are starting. No need of this part. So there are like different frames of detection. If there are like 10 cameras, you have the first 10 arrays, and if each of the cameras is one particular person, the one particular camera, so it's 1 out of 1. Okay, been streaming for what? 2 hours almost. Okay, I'm going to end the stream here for today. We'll have dinner, and then I don't know, I might start again. So yeah, if you like the stream, don't forget to like, subscribe, and follow, comment, whatever. And yeah, I'll see you in the next one.